Now this is what I'll do in this demo. First, I have two open Linux terminals from which I can work. Then I have one cluster shell terminal, and then on Linux I will generate I/O to an NFS mounted volume in the cluster. Then from the node shell in ONTAP I will monitor the consistency point types, and the command that I will use is systat-u, and the interval is 2 seconds. Now let's do it. So I've got my two Linux terminals at the top and my cluster shell at the bottom. I'm going to be using storage virtual machine SVM Blue, and there's a volume which is called blue_NFS. It is in node 1 Aga 1, it's 2 GB in size, and I have some space left. So I first have a look at the contents of my volume. I've got 367 megabytes of data in there. Now I go to the node shell of node 1 because that's where the aggregate is and the volume. And I run the systat command, systat-u, and 2 seconds will be the interval. So I look at the consistency point types, and so I'm going to follow all of these columns and see what happens. Forget about this time consistency point, that's because of the du command. Reading files also means writing access times. Now, but for the rest, this cluster is very quiet. So it's only zeros, there's no activity going on, and let's create some I/O. I'm going to run a small loop in which I create a tar file with the name of my Linux machine. So the tar file is going to be called Linux1, and the time command will register how long the command will take. After that I remove the tar file and the whole procedure will repeat. So I'm just generating I/O. And what you instantaneously see is that I have a full consistency point reason. The type is full, meaning my NVRAM is half full. And also, hashmark tells me that the next consistency point will be a back-to-back consistency point. Also, you see that the consistency point takes 6 or 8 seconds to complete. And so this system is overloaded. Obviously, it's only creating consistency point. Let's add another loop from the second Linux machine, and that will really bring down the system, so it's really suffering. It's only consistency points, so we have a problem performance-wise. You see that the time it takes to create the file will increase as well, from 24 to 28, and that will only get worse. So it's 41 seconds now. And my NFS client is even getting a stale NFS handle because of lack of response from the server. So let's stop the suffering and finish the loops. And after we've done that, the system returns to being quiet again. And we're done. So what we've seen is that WAFL is more than just a file system. That data has to pass 3 software modules before it can be written to the volumes. The software modules are Network and SCSI, Cluster Session Manager, and the data module. Then data will remain in NVRAM until a consistency point is complete. There are different types of CPEs that we had a look at, and back-to-back consistency points indicate performance problems. If you have any questions, please let me know.